Hi, hi guys. So nice to see that we have such a nice turnout. We have almost 90 people joining. Welcome everybody. So great to have you all here. And we're really looking forward to the really nice content that we have prepared for you. And I saw that some of you, actually quite many of you, have already introduced yourselves in the chat. And we're really looking forward to hearing more about you in a bit. My name is Joanna. I'm the head of events at Wear It Berlin, and I'm here with my colleagues that I will shortly introduce as well. This is a webinar that we organized, that is organized by Wear It Berlin, but it's in the framework of the Re-FREAM project, which I will tell you a bit more about in a bit, yeah. So I would like to also introduce you to my colleagues who also put together this webinar, and they are also here with us today. So maybe we can hear more from Anish. Let's see, maybe we have a bit of technical problems. We have, yeah, I don't know if you can see them. Do you hear him? Yes.
Hi everyone, nice to meet you all. I'm Anish Kakru and I'm working with the Wear It team as the Strategic Partnerships Manager. And during this wonderful webinar, I will be happy to answer any of your questions. So feel free to write any questions during our keynote speech or during our panel discussions in the Q&A section, and I will be happy to bring it to the speakers.
Hi everyone, my name is Anna and I'm a chat moderator, so I'm happy to see your questions, or I'm keep tracking the chat always. And actually I'm surprised how active our audience is and how diverse it is. So please keep writing.
Great, and thank you, Anish and Anna. And I would also like to introduce Thomas Gnahm, our CEO. Who's gonna tell us a bit more about himself and about what we do here at Wear It Berlin, actually.
Yeah, thank you, Joanna. I'm very happy that we can host this today. And thanks for coming all. Thanks for showing up. So, Joanna, if you can maybe bring up the slides that we have prepared. So, yeah, thank you. Wear It Berlin is a company that is hosting the Wear It Innovation Summit. Maybe you have heard of it. It's one of Europe's biggest events in wearable electronics. Our topics are textiles, electronics, startup scene, bringing together investors and startups. And here's a few slides and impressions of the last event, where you can see that really things come together that have been haven't been together for so long, like technology and clothing. That's our goal. We really want to build the industry here, because we think, if you think about it, our cell phones, they have developed so much. My grandfather hasn't had even a landline phone, but basically we were wearing the same clothes. So there you can see what kind of a gap we have here. So maybe if we go on with the next slide. Yeah, thanks. There you can see like the setting. We have a nice stage and the audience. We can learn, connect, and develop together. Exhibition area, we are now growing even more. Like as you can see on the picture, the space was too little. We need to grow more. That's why we also changed the venue for next time. And we really want to engage people, make business partners, help them to develop relationships. and inform the future of fashion. Yeah, we also have startup pitches that goes from smart underwear to safety clothes to to things that could change our daily lives. Next one, please. Yeah, like this tracking suit by Rococo, which is used by the gaming industry, for example. And they gave a presentation not only on stage, but also in between the audience members. And it was really exciting to watch them do this live. Yep. And Varied Berlin is also a product development agency. We support big brands and companies with their goals to enter the wearable tech market. There you can see the electronics that we do. This is for Elton shoes, something we implemented in a shoe. Here you can see the shoe, and the interesting part of this is not only that the shoe can light up, it's also that it's producible and that it really makes sense as a business. If you would like to know more about these kinds of things that we do, just get in touch with us. We are also working for other companies like H&M, or as you can see in the next slide, Siemens. We built this device for them that warns trail workers that repair the trails for train trails. It warns them from incoming trains, because I was also shocked by this, but every year 10 people die while they are constructing train trails in Germany alone. And in the 21st century, we're all still relying on human vision to tell people if there's a train coming or not. And this device can automatically warn workers if there's a train coming in. And it comes together with a software solution that's also cloud-based and server-based, and it connects to the devices. Yeah. So that's one of the big parts that we are working on. And another part is also supporting others with their work in wearable technologies. And yeah, let's have a look at the slide. The next slide, please. So one big part is the Re-FREAM project for us that we do for the European Commission, and we're really proud that we can do this. And I would like to ask Joanna, my colleague, to introduce the audience to this project and what this is about. So, guys, if you have a question, let us know. Now it's the right moment. Maybe Anna, do you have something? Is there a question from the audience?
Right now, we have just introduction from our audience, and it's very interesting to observe. We have people with different backgrounds, a lot of designers, people who do researches, and they just excited to see what's coming today and get to know more about smart textiles.
Great. Okay. Thanks. People keep asking questions. Now is the chance to meet the other people in the chat. We're bringing up a few poll questions as well. And now, yeah, Joanna, thank you for giving me the chance to introduce the company. And now let's go on with the webinar.
Yeah, thank you so much, Thomas. I hope it was as interesting for everyone else to know about all the exciting things that we are planning. Now I wanted to tell you more about Re-FREAM and what we do. So Re-FREAM is a project that's funded by the European Union, where the main goal is to find new ways of thinking about the future of fashion and what it means for us and what it means for society. We at Varied Berlin, our main roles are we are the hub managers of one of the 3 hubs. So it's divided. There are 3 hubs all over Europe, and Varied Berlin is managing one of the 3 hubs. And I will get a bit more into detail a bit later about this. And we are also managing the open innovation platform that we are building. Yeah, so as I said, we enable 20 artists with 55,000 euros each. And in each project is lasting 9 months, and we give artists the opportunity to work with technologists. So you know, we bring together the art and technology. So we bring together international artists with well-renowned scientists, and we give them the chance to push the boundaries even more and co-create and co-research. So this is a very big part for us in Re-FREAM to observe the transfer between art and technology. And we are super excited because we here you can see, for example, and this is a great example of co-creation in which the artists and technologies are working together. This picture was actually taken at the Fraunhofer Witsense facilities in a few months ago, and it's really an interesting process, and we're super happy to observe it, and we're looking forward to hearing more also about it from our artists and from our keynote speaker in a bit. And this is the Berlin hub. These are the three teams, the three artistic teams, together with the scientific partners and with the We're Berlin team, so the hub managers. And as I said, you will get to hear about it more in a bit. And also, if you are interested in applying, the second call is gonna start on July 1st. You can hear it. You can find out more about it on reframe.eu. And if I haven't managed to convince you to apply, I hope that our keynote speaker and our panelists are gonna succeed in doing this. So just to get started, I would like to introduce. You will, by the way, also have the chance to ask more questions about this in the chat. My colleagues are gonna signal me if there's anything happening. So don't worry, we'll try to answer all your questions and interact as much as possible. So I would like to introduce to you Christian Dils, who is a researcher at Fraunhofer Witsense. He is specialized on technologies for stretchable and textile integrated electronics, and he has more than 10 years experience in this. And he's one of the lead scientists for the projects in the Berlin hub for Re-FREAM. So Christian, how are you?
I'm fine. Thanks, Joanna, for the nice introduction.
Nice to hear from you.
Hi. I think I can start my presentation.
Yes, please. If you're ready, you're more than welcome to do so.
Okay, guys. Joanna, thank you for the introduction, and thank you for inviting me to give this keynote speech. Yeah, my name is Christian Dils, and as Joanna mentioned, I work for over 10 years at the Fraunhofer Institute for Reliability and Microintegration. It's called Fraunhofer IZM, here in Berlin as a research scientist, and my work focus is on stretchable and textile integrated electronic systems. So today, my audience is a little bit different than usually, but even if you're a beginner or already an expert in the field of electronic textiles, you will have sooner or later the problem to select suitable conductor materials or interconnection technologies for the integration of electronic into textiles. So in my short talk today, I will introduce you to 3 new and novel technologies that were developed in our research group that's called System on Flex here at IZM. And yeah, the goal of the new developments was to create reliable and industrially producible e-textile systems. While I'm giving this presentation, I will also show some application examples that have already been implemented with the here presented technologies. Maybe let me introduce you also quickly our textile lab here at Fraunhofer. Fraunhofer IZM is part of the Fraunhofer Gesellschaft, and we are specialized in applied and industrial contract research. So the institute focus is clearly on packaging technologies and integration of multifunctional electronics into systems. Here at Fraunhofer, we have been researching textile integrated electronics since the late 90s. And in, I see a poll. Since 2009, we have our own textile laboratories. They were founded for the purpose to have an interdisciplinary team working and sharing the expertise and equipment for research and development in the field. We call that lab Tex Lab, and we also have a new lab since 1 year. It's called TexBond. So what we're doing at Tex Lab, first of all, we examine electrically conductive materials for the required application. We test and analyze all kinds of metallized or metal coated fibers, threads, yarns, textiles. Then we also manufacture textile integrated circuit boards. Some we do with standard technologies such as embroidery, but we also have developed own processes such as thermoplastic-based soft circuits. I will introduce them later to you guys. Then one of our key focus is the assembly and interconnection technologies. We use processes such as low temperature soldering or conductive gluing to interconnect electronics with textile conductive material. But we also have developed more textile suitable contacting technologies such as adhesive bonding or ultrasonic welding. Also, encapsulation of electronic components is part of our research in the field. Then we have the hard and software design. Here the focus is on safe electronic functionality within the textile product. This includes textile bus systems with very, very long conductor lengths, EMC and ESD safety, but we also do a lot of miniaturization for the electronic components to increase the variability and the overall reliability of the system. Last but not least, we have a lot of testing equipment in-house, so we can test the system according to electrical, mechanical, or climatic standards, and we can investigate in detail the failure mechanism to obtain a deep understanding of the failure. We work with numerous customers and partners worldwide in all aspects of electronic textiles. This includes not only clothing, but also technical textiles, such as presented here, automotive interior or composite materials for lightweight construction. In the field of smart clothing, applications for health, therapy, elite sports, or protective equipment and workwear are in focus of our work and our collaborations. So maybe one introduction for our motivation. The fabrication of electronic textile confronts the industry with numerous challenges, since the manufacture of textiles and electronics is not comparable. The production facilities and the materials differ in a lot of, or in all kinds of respects. Textiles, you know it, are very slack materials, dimensionally unstable, anisotropically stretchable, but electronics are based on rigid or dimensionally stable materials or substrates. Then I get the pull away. So the problem with flexible circuit boards is that they can be bent only in one direction. So they are not body conformable and they are not textile conformable. To obtain textile characteristics, we have therefore undertaken numerous developments to make electronic substrates stretchable and therefore also suitable for the textile integration. We came up with a new word for this. We call it conformable electronics, and that includes also technologies for e-textiles and smart textiles. And what's our concept for that? First of all, electronic components are hard. So we take these hard components, we miniaturize them, and we place them on hard or maybe even flexible interposers or islands. And these islands are connected with stretchable conductive tracks in between. So we create the overall stretchable systems. And one of our main technologies, it's called stretchable circuit board technology. I would like to present it to you more in detail. This is a development that started 2005 in another European research project called Stellar. And this is also a success story for us because the technology has been commercially available for more and more industrial partners for a few years now. At the bottom left picture, you can see a commercially stretchable conductor tape from Word Electronics, one of the largest manufacturers in Germany. That is a company. We transfer the technology and you can order it from them already. What is really interesting about it, you can assemble electronic components using low temperature soldering processes. And you can also encapsulate the stretchable circuit boards with any kind of soft polymer as seen in this black sensor, photosensor. In the middle picture, you can see the maximum production site, which is also the standard size in PCB production. And what's also really interesting for us who works in the e-textiles field, this technology is based on the use of thermoplastic elastomer films, which is why we can laminate this soft thermoplastic circuit boards on all kinds of textile materials. Last but not least, interesting for the people working in the field of bioelectronics, instead of the usually copper conductor tracks, we can also use gold tracks, as you can see in the lower right photos, and that makes it suitable to be also implemented within the body. Last but not least, pre-assembled substrate can also be thermoformed 3D, as you can see in this 3D shaped lamp on the lower right side. The typical applications for stretchable circuit boards can be mostly found in the field of body-worn sensors. Body-worn sensors have a big advantage over conventional wearables like smartwatches because they can pick up the signals from the body where you need it from. So this slide gives you a brief overview of the already developed demonstrators and commercially available products, which are mainly for therapy, health, and workwear. In the area of fashion tech, still textile integrated lighting concept still dominate the applications. There's one example on the right side. So this textile integrated LED displays can ensure road safety, as demonstrated by the sporty superhero jacket, which was awarded the Red Dot Design Award in 2013. Or it can be also worn as a design element directly as a skin patch. And here in this project with Uncle Lo, it was used to visualize body movements. I would also recommend to check this video link. You can take a screenshot maybe, and you can really see that this is going beyond this traditional e-textile concept, because this technology can be stick to the body and can also take all the body movements and still fully functional. Then we also see a lot of, or we see current trends where health applications are combined with fashion design. Also, the next panel speaker, the Re-FREAM artists and collaborators, are working more in that field, and I think they will also give you more on the motivation goals and implementation of fashion and tech, or tech and fashion, after my presentation. Then this textile circuit board, it's a follow-up of the stretchable circuit board. The goal was to have, or the aim was to have a more mechanically highly robust printed circuit board that can be permanently mechanically deformed and is even washable. So we create this by replacing the copper film from the stretchable circuit board with a laser structured conductive fabric. The technology overall we use here, it's already available in the textile production, so commercialization of this so-called text PCB technology, it's conceivable in the near future. The first applications to be implemented, including RFID tags and textile labels, and also as work in progress in the Re-FREAM project, are dry electrodes for the EMG measurement. So this slide gives you a brief overview of the technology specification. If you're interested in that technology especially, please contact me afterwards. We are also looking for further collaborations, most likely in the areas of sensor technology or sensor application, and also the technology transfer into manufacturing for this text PCB process. Then once we have the textile or stretchable circuit boards, we also need the textile suitable interconnection technology. Now I would like to present you the adhesive bonding, which was also developed in-house. And the motivation for it, that during standard assembly of electronics, which is soldering, textile or particle from textiles, so-called fibers, can defect the manufacturing environment. Also, many standard joining processes require elevated temperatures. In soldering, it's usually, or the peak temperature is usually around 250 degrees. That would lead to decomposition or melting of most textile materials. So there's also a lack of suitable low temperature interconnection technologies, which is also hindering the spread of application for e-textiles until now. So the industry is extremely interesting in new contacting methods, which are working especially for electronic textiles. And this adhesive bonding was especially developed, which enables the integration of electronic modules onto textile circuits. A process sketch is shown on the top right. There you can see is an adhesive placed between a PCB and the textile contact pad, and then bonded together using a tool that applies pressure and temperature only to the contact area. This reduces the thermal impact, and at the same time also realizing a mechanical and electrically reliable connection. This technology is suitable for various textile integrated conductors, for example, for embroidered or woven ones. And since several contacts can be made only in one step, also multi-IO boards can be placed on a textile bus, as it can be seen on the lower left picture, where we created a tactile feedback system for our client. Last but not least, this technology has also another unique feature. It allows the thermal disassembly of electronic modules from the textile circuit board, and so creates new concept for recycling in e-textiles. Also something very important in the near future. Then, since there was no equipment available for this adhesive bonding technology, we developed and built our own bonder device. The video on the upper right shows the complete contact process, including the component pickup, alignment on the textile contact pad, the bonding process, and also the optical control. So with this bonder, it was just finished last year. We can now contact fine pitch modules on an area of about 1 to 1 meter. And first application, this textile displays can be also seen on this photos here. And yeah, with that, I only had 10 minutes. I come to the end of my talk, and thank you for your attention. Yeah, if you have any questions, please write here in the chat or contact me via email afterwards. Thank you.
Wow, thank you so much, Christian. This was really, really insightful. And I think for our audience as well. Thank you very much for taking the time to hold the presentation. And I'm really interested to find out what's happening in the audience, because I see that everyone is very active in the chat. So maybe my colleague Anish can let us know if there are any questions for Christian.
Hi, Anna. Yes, indeed, we have a lot of questions from the audience. So first of all, for Christian, it would be Merv Eidner, I hope I'm pronouncing that right, has a question that how do you think the smart textile market and the industry will be shaped after the COVID, so as per the current scenarios, and how will it affect the current market? So yeah, that's one from them. Christian.
Okay. I would think it will we will see more smart textiles product in the future, because what smart textiles also allow, it's a remote treatment or therapy of patients. And so I think we will see a lot more products in the near future in that field. And beside that, the smart textile have a bright future. If you think about security at work, if you think about all these health applications, which are already discussed, and startups or large companies working on that, I'm very sure we will see in the next years some really novel, innovative products. But the main issue, it's still the production of smart textiles. So that's why I was also focusing my presentation about these two new approaches to make reliable circuit boards and new approach to interconnect electronics. I think
great.
If this is more spread into industry, and the industry is unable to create products.
Perfect. I guess that answers her. We also have one more question from Ayaka Minami. So the question is it possible to apply stretchable electronics for hard paper? So that's like traditional paper made from woods.
Actually, we had a project in the past. We integrated textile RFID tags in the wood manufacturing.
Yeah.
So in that case, it was not laminated, but it was crimped on this tree.
Okay.
So, but I think on a thin, hard piece of wood, I think it should be possible, because you have a kind of rough surface, and there will be some adhesion between this thermoplastic-based circuits and the substrate.
Great. Perfect. I guess that answers Aika as well. And we have a couple of similar questions. So I guess I will sum these questions in one and just answer it. It's about the washability. So, for example, Saul Penius asked about, in some part, you mentioned about washable testing for TBC. And so it implies that now we can wash them and the circuits could still work. Is it still possible, or is it still in the testing phase, is the question.
We are testing washing, especially domestic washing in-house. I have one colleague, she's really an expert in washing smart textiles. This text PCB has a big advantage over the stretchable circuit board, because the conductive material can withstand more mechanical stress in the washing process. So once this material is fully encapsulated in a thin sheet of TPU or another TPE, it makes it really washable. So we don't have this typical break of conductive wires, for example, or conductive tracks, which are based on copper film, usually. So yes, so this is what we recommend to our clients. When washability is a key issue, please use or consider to use the text PCB technology.
All right, perfect. I guess a lot of questions are coming for you, Christian, but I guess I will sum up with just one different question. Maybe it answers other people as well. The question would be, are you working for the industry in Germany, or it's all over the world? And the follow-up question is, where is the highest demand as of now on smart textiles? Right. So, yeah.
First question is, we work nationally and internationally, and we work both for direct research contracts, but also in public funded research projects. And that we're doing most likely in Germany and Europe, but direct research interest we do internationally. And the highest demand in products I see in the health sector.
All right, great. Perfect, Christian. So thanks a lot for answering the questions, and thanks a lot for all the people who asked the questions. Now I guess I will head back to Ioana. And yeah.
Okay, side. Then yeah. Thank you guys. I hope you got my email. So if your question cannot be answered today, so please send me an email.
Thank you again, Christian, and thank you to our awesome audience who is super interactive, and I hope your questions got to be answered. If not, as Christian said, you can approach him, or just as an information, we have also a LinkedIn group where we discuss also similar things like this, and so for example, Christian or our artists, they post the developments of their projects there. I don't know if my colleagues have already posted the link to the LinkedIn group yet in the chat, but if not, we're gonna do it shortly. Again, keep the questions coming. That's really great. We're super happy to hear from all of you. And to continue with our agenda for the webinar, I would like to introduce the moderator of our panel discussion, Christiane Luglibert. She's a university professor and a lead for fashion and technology at the Kunstuniversität in Linz in Upper Austria. So hi, Christiane.
Hi.
Hi, welcome. Thank you so much for agreeing to moderate the panel discussion.
Yes, sure.
I know that your expertise is very much welcome in finding out more about the artists and their projects.
Yeah, nice to be with you. I even saw in the list of people, there are a few Re-FREAM people and other people we work together, so hi to everybody. The panel discussion we do in a way that first each artist will introduce him herself with a few slides, and then we do the discussion. So first, I want to introduce you to one of Hub Berlin Re-FREAM artist, Giulia Tomasello. Giulia is an interaction designer, and for her project, she already received several awards. Also the European Starts Prize in 2018. Hello, Giulia.
Hello, everyone.
And also an award in Japan, the Omosi Roi Award. I always hope I pronounce this right. I think it's a difficult word. And your aim as a designer is to innovate women's healthcare, combining biotechnology and interactive wearables to raise awareness and provide alternatives to intimate self-care. So I think it's really a very interesting Re-FREAM project. So maybe you can talk a little bit about it.
Sure. Okay, so let me share my presentation as well. Okay, you can see it?
Yes, super.
Okay, so everybody, hello, I'm Giulia Tomasello. I'm an interaction designer and I'm Italian, but at the moment I'm based a little bit everywhere because of my work. So in my field, I work from biohacking, wearable computing, digital fabrication, and biocouture, that are different, like we can say, field where technology and the body are kind of playing together. So I really try every time to question this interaction between the human body and technology. And I do it especially in the field of women's healthcare, and especially on the field of women's social taboo. So Alma is the project I'm going to tell you a little. That is also part of Re-FREAM Fund, and it's a wearable biosensor for monitoring vaginal fluid. The project started because there are the 75% of women that can suffer of vaginal infection worldwide, at least once in their lifetime. And from the 75, 8% can be a recurrent, meaning that they can have it a lot of the time in even a year. Therefore, we are developing a wearable biosensor that will be placed in the underwear and that can monitor the pH and lactic of vaginal fluid to try to prevent early bacterial vaginosis. Then this data will be sent to the phone, so the user will have an app that she can track and monitor her health every day, or mainly when she will have symptoms. So I'm working with my partner, Tommaso Busolo, at the Carnarian Lab at the University of Cambridge. So we are developing the pH sensor, and we are also developing the old prototype of Alma, taking referencing from like smart pad or smart tampons. So really going through, understand how technology can really play a role in the healthcare and in a topic that until now is still considered a taboo quite everywhere. And what we are doing also is a kind of low-tech version of Alma, so with no technology. And at the moment, since I'm at home, I'm developing biotextiles based on agar-agar with natural pH, so with red cabbage, to try to see if the vaginal fluid can really change the biotextile, and so we can have like a color change in as a response that something is happening in our fluid. And particularly, I'm working also on the user experience of Alma, because one problem of technology is that most of the time we don't talk with women. So I'm making a workshop with different women all over the world. For now, Rio de Janeiro, Milan, Bangkok, Penang, and Switzerland, where we are really trying to co-create the prototype together with women. So if there is any women's organization in the audience, please let me know, because I would love to collaborate with you as well. We are also doing a survey that we just launched and that you can find online. I'm going to send now the link to really talk with every woman that actually we can't reach through the workshop. And a last call, I'm inviting fashion designer to actually collaborate with Alma. So if you are based in Brazil, Italy, Thailand, Malaysia, or Switzerland, you are a fashion designer working on the smart textile, please let me know. That's it.
Super. Thank you, Giulia.
Thank you.
As the next artist, I would like to introduce you to Jessica Smarsch. Jessica, are you here?
Yes, I'm here.
Yes, super. So Jessica, she graduated from the Rhode Island School of Design, and you have a background in textile design. You worked as a textile designer in New York for several years, and then obtained a master in the Design Academy in Eindhoven. Mm-hmm. And in your research project, Constructing Connectivity, you aim to disrupt the standards of healthcare. So one of the most important fields for the smart textile. So let us know a little bit about your project.
Okay, great. Also share my screen. So, yes, I'm Jessica, as Cristiano already introduced, and I have a background in textiles, but I started to make a shift over the last few years, as you'll see as I go through the slides here. So Constructing Connectivity is a system for helping stroke patients to rehabilitate from home. And it uses a wearable sensor garment to measure movement and muscle activity and deliver audio-visual feedback to stroke patients through a connected app. A stroke occurs when oxygen cannot get to the brain, and it causes the neurons in the brain to die. So this occurrence in the brain results in some form of physical paralysis for many stroke patients. And Constructing Connectivity brings a person-centered approach to medical technology, and that's why I say it disrupts the medical industry, because just like this Kintsugi plate that we see here, the goal is to emphasize that beauty can come through the repair process. So our mission is to use beauty and creativity to sensitively stimulate and engage patients. So here you see a woman practicing activities in the home and receiving both creative and quantitative feedback. So as Christian mentioned, Constructing Connectivity began in 2015 as my thesis project at Design Academy Eindhoven as a method for translating rhythmic body movement into textural designs for woven clothing. And then in 2017, I began transforming the concept into the current platform. So instead of weaving textiles, the pattern making process is linked to rehabilitation exercises. And the reason for this is that research indicates that linking multisensory feedback to patients' movements can attract more neural connectivity in the brain and help patients to make more new neural connections. So this project has benefited from 3 product development grants, and each iteration has seen advancements in the concept and design. So with the Re-FREAM grant, I'm currently working with Fraunhofer to create the electrode designs that you see here on the arm in the upper right. And this uses a process that Christian talked about and that Fraunhofer developed, which laminates conductive textile inside thermoplastic material, which can be laminated to textile. And soon we will begin now the interconnection between these text PCBs and the electronic processing module. You can also see that the design of the garment has evolved to a very minimal design. So just sleeves covering only the arms and shoulders where the electrodes need to be. So now we are at the stage of the development where we want to move from the technical requirements of the electrodes into the functional requirements for wearability and comfort, and also consider the aesthetic impact that the garment can have on the patient's mental and emotional well-being. So here the idea is to have a fine inner sleeve where the electronics are laminated, and then a second cover layer which can have areas that tighten around the sensors, which helps to improve the sensor feedback. And this second layer can also complete the garment and add a sense of comfort and beauty through the materials and the design.
Can you hear me? Yeah, now I have sound. Thank you, Jessica. Now I would like to introduce the third artist, and the third artist are actually 2 artists. It's Emanuela Corti and Ivan Parati. Hello, both of you. Hi.
Hello.
And they formed together the design team Witsense. You are both coming from the field of inclusive design. And Witsense aims to improve the quality of people with learning and development disorders. In the Re-FREAM project, your project is called Lovewear, and it's a smart underwear that helps people of all abilities to self-explore and enhance the intimacy and the sexuality. So we are very curious to hear a few words about your project.
Sure. Let me introduce the project. Let me share the screen. I'm Ivan Parati from the Witsense team, and I introduce you to Lovewear, a wearable system that applies soft robotics to empower movement impaired to explore their own intimacy. Disabled sexuality is often neglected to release caregiver and families from uncomfortable responsibilities, which pose moral and ethical questions. Whether the individual is deprived from his or her natural appetite or emotional and sentimental implication, what is really missing is the self-consciousness and awareness toward his or her own body. We want to give those people and their families some dignity through a technology that can let them explore their sexuality autonomously. We are focusing for the Re-FREAM grant on the female version, and that means that the wearer needs to feel sexy while wearing it. Lovewear system is composed of 3 main elements: underwear panties, an external case unit, and a pillow. The underwear panties include some isolated chamber to generate a more natural sensation of a tactile movement on the skin surface and the genitals. The external unit contains pumps, mechanical parts, and electronics. We were initially envisioning something more portable, but as a first prototype, we thought it was a good idea to focus on performances to maximize the tactile effect. The pillow is an important element of the system since it works as a magnified interface where user gesture translate into underwear feedbacks. We are thinking anyhow to a growing system which functionalities could be extended. It is a challenging multidisciplinary project, and our research and prototyping activities are directed toward multiple goals. We are working with an association through a psychologist. We are collecting a screening survey and research about physiological and psychological dynamics involving arousal and intercourse. We map the sex toys industry where there is already a range of products dedicated to disabled users. What we are focusing at the moment is the simulation of patterns that will generate dynamic behaviors on fabric once the fluid will flow through their cavities. This was initially planned to be a physical prototyping experience and one of the objectives of our co-creation activities at Fraunhofer, Berlin. But since the lockdown is affecting our work plans, we took it as an opportunity. We realized that we could improve our chances of success modeling our prototypes in a virtual environment, and a popular software became handy to our task, which we are using to generate the patterns that we can see in the simulation that is running in the video. And I'd like to thank you for your attention, and I hope to have the chance to connect with you soon, later on, after the panel discussion. And thank you.
Thank you. Thank you, Ivan. Yeah. So, are you all here? 3 artists? Yes, Jessica is here. Giulia. I want to start with a question around this art-tech collaboration. One of the very specific topics in Re-FREAM is this art and tech that the artists collaborate with the scientists. So my first question would be to Jessica. How do you experience this art-tech collaboration? How is this for you?
Well, I really enjoy it, especially because I think this is the first time in the evolution of the project that I'm seeing real results with the work in terms of the functionality. So it was really interesting from the beginning for me to learn from what Christian has already developed, what he already knew could work or not. And so the first months we were really focused on what are different solutions we could try to get a product that works. But even so, even though we were so focused on the functional part, there's still a dialogue between, how do you actually make it? So there's that. But now as we're starting to kind of move into making a prototype, I mean, to me, what's also really important is to not just make a functioning medical product. In fact, that's sort of my criticism from what I see out there already. What I really want to bring is something that also enhances the emotional experience of the patient. And that's where the design comes in. And something that, as you saw in my presentation, I show on the armband is inside out because I want to show what the product looks like. When that's turned the other way, everything we're creating becomes invisible. So that was sort of something that came to my mind about what might be interesting is to use this kind of sheer knit construction that would actually reveal this, you can say beautiful technological structure that we're creating on the inside. But now I'm working with a company to advance on that. And now the next steps will be what we make in the knit. How is that going to relate now when I bring it back to Fraunhofer and we have to apply the electronics? So I think it's a back and forth, and at every stage, I'm in communication with Christian to kind of like check in how it goes.
I saw also that on the list there are some designers listening us. So maybe also an interesting question would be, how deep did you dive into technology? How quickly did you speak the same language with Christian? Was it difficult to align the project, to understand each other?
Is that a follow-up for me, or?
Yeah, it's a follow-up for you. I was in because I thought this for designers it could be really interesting. How deep do you have to dive into that technology?
Yeah, I mean, of course, like I am never going to have what Christian has in his brain in my head. I mean, but it's also not necessary. I mean, I don't find any problems with it because he's able to sort of inform me about the things that are important. And I find it quite understandable. Also, I mean, a lot of what we're doing is like, I'd say material science. So that part is quite easy to connect with. Some areas where I've had to learn a little bit more is really about how the electronics part work, and then but it's still, I think he's able to explain things enough that I start to become familiar. And I think as a lot of designers, I learn when I actually do it. Probably a lot of people in general. So talking is one thing. It's when you're actually in the lab making it, then you say, oh, okay, it's not, it's not so difficult, not so inconceivable.
Yeah, interesting. And Giulia, how about you? How did you experience this co-creation? What was the main challenge for you in this co-creation process? I think you are muted. You have to. Now it's good.
I was okay. Let's say that I've been always working on a multidisciplinary field, so always trying to co-create with different. Like in different fields, like with different like skills of people. And I found it very interesting now to work with somebody that can also be linked to a company. Because of course, like most of the time we work between freelancers or PhD students. So this time my head is changing, thinking that actually we are producing something, we are like designing something that can be one day maybe on a line for a production. So actually, that is kind of changing my way of co-creation, and I'm developing much more also the language that I need to kind of create in between different skills. So really like to fill the gap in between like me talking with a scientist. So every day is a constant learning, and I'm quite happy to work with different people, because I think it's the best, especially for us as a designer, because otherwise we will always kind of be in the same small circle. But actually, if we take feedback all the time, even from the fashion, but also from the psychologists, like the doctors, it's just like enriching the whole project and making it more complex. So it's great.
And Ivan and Emanuela, what was the main learning for you out of this co-creation? Because the goal is also like the scientists learn in the co-creation from the artists, but also the artists learn from the scientists. What was the main learning for both of you?
Well, I believe we are learning every day, actually, because since this is a multidisciplinary project, actually there are a variety of aspects that are included. So the technological aspect, material engineering aspect, psychological aspect. So we are facing every day the psychologists, for example, and we learn a lot of things. Actually, now we just started to distribute a questionnaire among people with disabilities to learn more about their direct experience. So I believe we will learn a lot more. Of course, we are learning also a software. Especially because of COVID, we can't access any lab. So we are experimenting with the software, simulating the inflation and deflation of the material. So I believe every day there is a new challenge or something new to learn.
And from the co-creation phase with working with Christian at Fraunhofer, I believe it's also important to find a common terminology and common language that we need to share while working, because most often designers and scientists talk a completely different language. So but we are also often aiming at the same goals. So we need to align first on these languages and vocabularies and terminology, and then everything becomes quite easier and quicker.
In fact, how is this situation at the moment affecting you in the co-creation? Can you somehow continue the process, or is this on hold because you need the lab?
Yeah,
how is this for you?
Partially it's on hold, actually.
Partially no, is on hold, but as we said, we took it as an opportunity to use this software, and that would simulate the inflation of the fabric, and then we can kind of augment our productivity in this way. So once the lab will be open again and we'll be able to access it, we can select and we can test a much wider range of different samples, and we can select, pre-screen how those sample works in the virtuality. And we are also working with a material engineer in our team. And while Valeria, she's also part of the audience.
Hi Valeria.
And she will take care of the more scientific and measurable data of these experiences, working on pressure and the flow and the volumes of the inflatables, while we are working more on the how the fabric reacts on our virtual simulations. Yeah, so at the moment, it's the impact is there, but we're kind of making virtue out of it.
Yeah, even another collaborator who is Ison, who is also in the attendees, was supposed to be in the lab. So at the moment, she is collaborating remotely. And yeah, we're looking forward to do some practical tests. But at the moment, we don't know really what to start.
Imagine the same for you, Jessica and Giulia.
Yeah, well, we were kind of always somehow in a smart working, because I was traveling and my partners in the work are based in London or Cambridge, and then Kristen and the others are in Germany. So now we just moved from an high-tech version to think also the low-tech version. So I'm really in a kind of DIY at home, working with biotextiles. And then our engineers are working more to demonstrate on a field like the hypothesis that it will work. And then as soon as the lab open, we go back to test it. And we are also really focusing on the user experience part. So now that I have time, I'm really just diving through like different communities, and also I'm developing now the workshop that I was doing in real. I'm preparing it also online. It's going to be exciting and challenging, but I'm really trying to really take this time to research what we women really want, like from more an educational point of view.
Yeah, I mean, I would just quickly add that, like, I feel fortunate I've been able to find, for example, a manufacturing partner that or development manufacturing that I can already start working with. I think the harder part is that I'm working in healthcare, and the therapists that I normally would contact, their clinic has been turned into a COVID-19 hospital at this moment. So, that is something that adds a challenge. But actually, in general, I feel pretty fortunate that it hasn't stopped the project for me.
Yeah, good. So it sounds quite good from all of you. I was wondering, for this co-creation, is there any question from the public? Now, Joanna, I just don't know how I see if people have questions. Would you tell me if there are questions for the co-creation from the public?
So I would like to ask Anish because he's the one monitoring our Q&A section. And as I understand, there are some questions for our artists. So I'm going to give the word to Anish.
Yes, Joanna and Christiana, we have a lot of questions from the audience. And it's like really great to have such a positive response based on all your 3 projects that you're doing. So that's really positive. That's really great. So firstly, I would like to ask a question from Silke for Giulia. That would be, firstly, she congratulates on your project. And her question is that, is there any restrictions in terms of countries or specific demographics or regions regarding the call of fashion designers for your project? And if yes, why?
Well, the restriction I created kind of, or let's say I address it to the countries I've been developing already a workshop, because we have been collecting data. So we have been collecting local data specifically from these countries, and it will be interesting to see how fashion designers based in that countries can develop their own version of what it could be the Alma Andis. But let's say that I'm open. I mean, it's really like another aspect of the co-creation, really trying to see how this project can also be perceived from an artistical aspect, because what we are going to develop is something functional, which can probably not really respond truly and fully of a kind of fashion tech that you could see on a catwalk, but much more something that you could see one day on in the shop and then in your cupboard to use it. So let's say that I'm open. So please just text us, just email me, and we can talk about it. I will be very happy.
Great. I guess that answers more or less the question for her. Perfect. One question specifically for Jessica. It would be based on the sustainability aspect. So the question is from Patrick, and he's asking, like, how are you considering the sustainability aspect with respect to the end of life of your potential product? So how would it be at the end of the cycle, and how are you supposed to deal with it?
You're muted.
Sorry, forgot to unmute. Yeah, I mean, at one point there was an idea of being able to exchange the sleeves, but currently something we've been looking at is just about like the product itself, how you separate the electronics from the rest of the garment, so that it could be recycled and reused. So, I mean, if you think about the sleeves, there's the textile component, and then there's the text PCB that's laminated, and then there's the electronics. So one thing, in terms of like a business model, one idea is about how to get patients to return the product so that we can, for example, reuse those processing modules. I mean, that makes a lot of sense if we could reuse those modules. And then another thing in terms of material sustainability. So one test we did earlier was just to see, like, can you delaminate the text PCB from the textile after you laminate on a fabric? And by reapplying heat, you can. But something that's interesting now that we're starting to trial is within the knit design itself, knitting with a TPU yarn in the areas where the text PCB should be laminated. And yeah, the idea there being that it's very easy then to separate, very easy maybe first to laminate it together, but also to separate exactly where those electronics are from the textile so that there can be recycling.
All right, great. So I guess, yeah, that pretty much gives a clear picture to Silke in terms of like how it happens. So yeah, thanks, Jessica. And then the last question, I guess, for Ivan and Emma. So that would also be from guest Tasia. So she asked, like, how difficult is it for you guys in terms of being independent designers to develop smart textiles, or like to source your e-textile componentry? So yeah.
Yeah, we are independent designer, and but we have a small startup and a partner based in Italy that is already a pioneer in conductive yarn and sensorized garments. So kind of already introduced to the environment for us is kind of easier. But I believe there are plenty of platform online nowadays where people that are approaching this field can rely on in order to find resources in general, but also sources of supplier. And of course, nowadays, suppliers are not always demanding for quantities, but they can also provide a small amount of products for testing and for sampling. And so it's becoming more and more, it's becoming easier for designer to test and also to use simple prototyping devices and a platform like Arduino and other stuff that can be customized or can be kind of turn into your own specific tool. So I think it's difficult at the beginning, but then once you get to know the environment and the resources, it's becoming quite easy. And there are plenty of platforms that offers like small quantities or tailor-made kind of solution for people that are doing their own projects. So I believe you will be in good hands.
Great, Iman. I guess this helps a lot. Yeah.
Sorry to interrupt you. I've seen there are a few questions in the Q&A. I don't know whether we should answer now.
Maybe we can leave our context.
Exactly. So the part of the thing is like we are also answering these questions separately, but it's also like we're bringing in to have a broader discussion. So yeah, so we are also doing that. Great. But also, I guess it's like a very good approach you said, because we have a lot of aspiring new designers who want to do and be something like you. And that helps you in the way, like you explained, like now with the resources, you have a lot of potential in the market to come up and develop something which you are doing. So I guess that's a great thing as well. So I guess from the Q&A section, that would be it from I, because of the time constraint. And I will give it back to Christiana.
Yeah, thank you. Even I had some questions and they are also now already answered. So this was similar question than from the public. Joanna, do we have still time for a few questions?
Maybe Joanna did us
I think maybe one more question.
Yeah.
Yeah, I think
I had more another question for Giulia, more for the product itself. Do you already have experience for this digital function of your product for your client or for the potential user? So how does the people react if there's now, it's not underwear, but it's an underwear who has a function, can do something, and a digital function? How do the people react to that?
Well, this is an interesting question because actually the field is quite new. Well, let's say that wearable technology is there since a while, but in the market we can't really find wearable technological clothes, but much more accessory. And then when you talk about lingerie, and you connect technology, yeah, it can be scary at the beginning. This is why somehow I'm developing the workshop, because I need to understand how far I can go even to integrate a specific technology in the underwear, because we're talking about something very intimate. And also the whole intimate care, I believe that has been never really talked through. So even between women, we don't really have the knowledge or the method, not the knowledge, let's say, to talk about it truly. So I'm really trying with the workshop and with the survey, which is also made kind of with question and some educational part, to really understand truly how I can help. Because really this project for me, it's mainly for us, that we have these issues every day, or during our, well, every day hopefully not, but during our life. And so I hope that by just integrating the user itself in the conversation, so this participatory design, I can make something that then they can find it interesting. Because I'm sure that if I will just place it now in the market without zero explanation or integration for them to understand what it is, of course there will be no client at all, because it's just something too new and too scary. So you need to really create a field now. And I guess that our 3 projects are really based on this, really like trying to create like to the user like a comfortable scenario where they can see using the product we are developing, that they are the 3 of us, like we are really work on the edge of healthcare and technology. So.
Very interesting. Joanna, I would have 2 more very short questions. Do we have time for that, or we are running out of time?
If you manage to keep it really, really short.
I ask for very short answers,
Yes, please go ahead.
Jessica, your project looks to me already quite close to a commercialization. Are you in contact with people to really bring this on the market in a very short time?
Well, I wouldn't say very short, just also because medical technology, it's, you have to prove that something works and there's trials you need to go through. But on the other hand, it's getting closer and closer. So now I've partnered with Knitwear Lab in the Netherlands, and it's I recommend to anyone listening, if they're looking, knitwearlab.nl. What's nice is that we'll be developing the prototype together, and they have connections for producing it in other factories. So that then I'm looking forward then to understanding how we can go from making the prototype to understanding how do you actually scale it up.
Yeah, great. And I have a last question. Is Christian still, can you hear us, Christian?
Sure, I'm still here.
Yeah, good. I have a last question to you and to Ivan for maybe just 1 or 2 words. So what, in your vision, what is the next very visionary product? Like, what is the next iPhone? What do you think will be the changing product? No, this is or Ivan, do you have something, a last statement?
Wearable technology. No, just I would say wearable technology, because so far, if you mention that to anyone, they would think about smartwatch or something like a gadget, but nobody immediately connected to something, that clothes that you wear and they do something and they collect something from yourself. So, but I would say as well that this innovation won't come from the industry, the traditional industry that is addressed to, like, fashion, for example, fashion industry, extremely refractarian to innovation. And if you look at emerging technologies like a self-driving car, they don't come from car manufacturer, they comes from outsider of the game, like Google or Tesla, for example. So I would say that who would innovate the wearable technology and the fashion industry in general would be an outsider of this field. Not sure about what will be there, like display kind of sweater or some sort of like definitely augmenting. So there are different direction we can explore, but something would be there soon. I hope.
Yeah, thank you. Great. Thank you very much to all of you. I think if there are questions from the audience, you will see that, right?
Yeah, we still have the chat option. Thank you so much, everybody. Thank you, Christiane, for moderating the panel discussion, and thank you to the Berlin artists for sharing their experience so openly. And you are definitely all displaying perfect examples of co-creation and our tech transfer. And we work really close with all these projects, and we know that they really put their hearts and souls into their work. And we're super excited to see the prototypes at the end of the first call. So thank you again, everybody. And I would like to maybe hear again from the audience. Let's see what's going on there. Maybe Anna, my colleague, can jump in quickly and let us know what's happening.
Sure, I would like to give a small overview of people who we had today in our audience. It's nice to see how interactive they are, and we have people from Finland, Spain, Argentina, Japan, Germany, and America. And what is the most interesting, we have 33% of creative people who are interested in a topic, and also 11% of people would like to find a solution for their future products. Also, half of the audience already worked with smart textiles, and 34% would love to be a part of a project and apply as an artist to Re-FREAM project. Also, from our poll, we can see that in 5 years, products, probably like textile products, probably will be available on the market. And this is, I would love just to do a small overview what's going on in our chat. So right now, maybe I can give word back to Jana. Thank you for chatting.
Thank you, Anna. Thank you so much for the overview, and thank you for our audience for interacting so much with us and telling us their opinion, telling us what they're up to. And again, thank you. Thanks for everyone. It's really cool. What I also wanted to share with you guys is that Wear It Berlin is launching a series of events. This webinar was part of the Re-FREAM framework, but we're launching a series of online events, and we're happy that you are gonna also join us there. Just keep, sign up for the newsletter and follow us on social media, and you'll find out more information about this. Unfortunately, we're really behind on time. So the breakout rooms, we promise we will we will experience this in the next events. Maybe some last words. As I was telling you earlier, there are 3 hubs in Re-FREAM. We are the Berlin hub, but there's also one in Linz and one in Valencia. They are focused on sustainability and 3D printing. And the second call for the Re-FREAM project is going live at the beginning of July. So you can start applying if you think one of the 3 challenges applies to you. We would love to see your projects and maybe get to work together in the second call. You already got to see a bit of how co-creation works and how it looks like. And I hope it motivated you as much as we enjoyed sharing. Just another reminder, we also have we have a LinkedIn group where all of our artists, for example, and scientists in the Re-FREAM project, and not only, a lot of people in the industry are sharing the development of their projects. They're sharing insights. They're looking for people to collaborate with. So we really we invite you to join our LinkedIn group. My colleagues posted it already in the chat, but I think we posted it already. So please join. Let's get in touch. It's a perfect opportunity to get in touch with us, with everybody. We really appreciate your feedback. So we would love to get yours on the event that we did today. You're gonna automatically receive a Google form, and I really hope you fill it out and you tell us what you thought. Thank you again to Christian, our keynote speaker, to Christiane, who moderated the panel discussion, Ivan and Emma from Loveware, Giulia from Alma, Jessica from Constructing Connectivity, and last but not least to our Wear It team. I think you can also see them on the screen. And thank you again, everybody, for participating.